Hi! In this video, we are going to investigate the physiological mechanisms involved in seed germination. Germination is a process by which an organism starts growing as a seed and develops into a plant, and its growth is affected by several external factors such as water, oxygen, light, and temperature. However, the process could be prohibited if a seed is capable of seed dormancy. To fully understand the concept of seed germination, including its external factors and how seed dormancy could be broken off, several experiments are done. First, the effect of temperature on seed germination was observed by placing 20 radish seeds in petri dishes with paper towels moistened with 10 milliliters water and placed in different setups with different temperatures such as refrigerator, improvised oven, and control setup at room temperature. The seed germination is observed for 6 days, and the hypocotyl, epicotyl, and radical of germinated seeds were measured. After 6 days of observation of the radish seeds, the control setup that is placed at room temperature starts germinating on day 1 and completely germinates the 20 radish seeds on day 4. As for the radish seeds placed in an improvised oven, it showed that the 3 radish seeds start germinating on day 4 and 5 radish seeds on day 6. While the radish seeds placed in the refrigerator only expanded on day 2 but did not continue to germinate. In terms of the measurement of hypocotyl, epicotyl, and radical of the germinated seeds, it is shown that there is a higher average of measurement in the control setup. The results imply that there is a higher rate of seed germination in the control setup that was placed at room temperature between 25 degrees Celsius to 35 degrees Celsius. The temperature lower or higher to this would result in a declining rate of seed germination. Four similar microwavable containers were prepared, and 20 uniformly sized radish seeds were picked for every 4 containers. Paper towels were put into these empty containers to serve as water absorbent and source of water for the radish seeds. A partial amount of water was sprayed onto the paper towels, and on it, every 20 seeds were lined up. The 3 microwavable containers along with the suspended silica gel were put inside an airtight container, while the 4th container served as control, where it was stored in a cool, dry place. This process lasted for 6 days, and throughout that time, it was prohibited to be opened. After 2 days, it was observed that the seeds in the airtight container had already germinated, while the seeds in the control setup expanded. On the 4th day of observation, the seeds from the airtight container had already formed their hypocotyl along with their radical. On the other hand, the control seeds have not shown any changes. On the day of measurement, the 6th day, it can be seen that the hypocotyl becomes longer, while the radical has already formed root hairs, and some already have an epicotyl. The control setup had already germinated, where most have already grown a hypocotyl and radical, but none has grown an epicotyl. The materials used are radish seeds, distilled water, paper towels, and microwavable containers. First, paper towels were laid on the empty microwavable containers and were moistened with an ample amount of distilled water. For every container, 20 seeds were lined up. For the setup, which requires light for an entire 6 days, artificial light was used whenever the sun was unavailable. Another 3 containers were stored in a dim part of the room, and the control was placed in a cool, dry place where it interacted with both light and the dark.
After 2 days in the light setup, some seeds had already germinated. Respectively, 8, 11, and 13 were total count of germinated seeds for each microwavable container in the light setup. In the dark and control setup, seeds only expanded but no growth was observed to occur. On the 4th day, in the light setup, all microwavable containers containing radish seeds had already germinated, while in the dark setup, 20, 8, and 5 respectively had germinated. On its last day, all the seeds in the light setup had already germinated and its seedling parts were already visible, while in the light and control, there were seeds that had not germinated.
Seed dormancy is the incapacity of a viable seed to germinate under favorable conditions. It is significant for seeds because it is useful for their survival in unfavorable conditions. Rice seeds is one example of seeds that is capable of seed dormancy for having a seed coat or hull that prevents the entry of water and oxygen into the seed, leading to the prohibition of its germination. 2 experiments are done to observe how seed dormancy can be broken down. Rice seeds were initially disinfected using 6% hypochlorite solution for 10 minutes. After 10 minutes, the seeds are washed thoroughly with running water. The paper towel was put in a container lid and moistened with 10 milliliters water. After that, 20 seeds per container lid were put in a moistened towel. The setup was triplicated and placed in an improvised oven with light, and 1 control setup was also done, and hypocotyl, epicotyl, and radical of the germinated seeds were measured. The results show that there is observed germination in 3 replicate setups placed under the improvised oven, while the setup placed in the control setup does not show any germination of the rice seeds. The seeds placed in an improvised oven showed a higher rate of germination because the seed dormancy of the rice seeds broke down by the dry heat. The rice seed is capable of dormancy since it is protected by a hull or outer seed coat that does not allow any water or oxygen to pass inside the seed to start the process of germination. The materials that are used are rice seeds, container lids, paper towel, distilled water, and 6% hypochlorite solution. First, the rice seeds were initially disinfected using 6% hypochlorite solution for 10 minutes. The seeds are washed thoroughly with running water. Then, the paper towel was put in a container lid and moistened with 10 milliliters water. For the control setup, 20 uniformly sized seeds were selected and sewed in a container lid with a moistened paper towel. The hull of the rice seeds are removed while making sure for the embryo not to break off, and the hypocotyl, epicotyl, and radical of the germinated seeds were measured. On the last day of observation, 5 seeds germinated in the control setup. Meanwhile, 19 seeds germinated in experimental setup A, 18 seeds in experimental setup B, and 20 seeds germinated in experimental setup C. The results of observations show that the removal of hull in rice seeds is effective in breaking the dormancy of the seeds and increasing the germination of the dormant seed. The germination rate of the removed hull rice seeds is greater than with rice hull. The seed dormancy of rice seeds belongs to the category of exogenous dormancy, which is caused by conditions outside of the seed embryo. Since the rice hull is too durable for moisture to infiltrate, therefore restricts the entry of the water and prevents germination. On the other hand, when the embryo gets an appropriate environment, such as adaptive moisture, the nature of the dormancy stops. Since the hull was removed, the seeds becomes permeable. Hence, the water can penetrate to the seed and increase germination. That's it for the activity of seed germination, and we remind you to keep calm and stay curious. Have a nice day!